Right. Good morning, my dear students. uh, we will continue from the last session that the problem that is being taken is the springing points at uh, different levels. Okay. So in the previous session, it was seen that how the support reactions are being solved. Okay. So we have got the support reaction values as reaction at A, it is 65 kilonewton. And if you remember in the last session, we have solved for support reaction values, RAY value and RBY value. HA is equal to HB is equal to H, that is 133.33 kilonewton. Right, so these are the three values. In the other way, four values HA, HB are of same. So it's very clear that you need to use the same four equations that we have been using for solving three hinged arches. Three equilibrium equations and one equation where hinge is available, moment at hinge is 0, the crown point. And now let us see the remaining part of the question, that how to find maximum bending moment in the arch. So if you observe, uh, uh, even prior to solving for maximum bending moment where it occurs, by logic you can you can assess where the maximum bending moment occurs, or otherwise you can even prove that also how your logic is going to be correct. Okay, right, let us see that the load in portion BC is higher than no the load in portion BC is total, what is the value, 10 into 15. So 150 kilonewtons is the total load in portion BC, whereas total load in portion AC is only 50 kilonewtons. Means the load in portion BC means to the right of C is 3 times more than load in portion AC. So hence we are able to decide or guess, I can say, you can easily guess that the maximum bending moment is in the region BC. Okay, right. So if you want to search or prove that what your guess is correct, now in this problem we will see what is the maximum value of bending moment which occurs between all the salient regions. What you have is portion AD is one region where you can have a moment equation, single moment equation, and also portion DC where you need one more moment equation, mx. Okay, because you have a point load at D, so you cannot use mx equation for portion AC, single moment equation. Okay, right. Now let us see the other region is BC. So you have a moment varying in a D region, so you have a maximum value there or minimum, whatever it is. And portion CD, you have moment varying, moment values varying and you can have either maximum or minimum in this region also. And portion BC also moment varies, so you have different values at different locations. So where that also will have one maximum or minimum value. So among these three, which is maximum? That is what is asked here. What is the maximum bending moment in the arch? Okay, so each region will have its own maximum or minimum value. Say portion AD may have a maximum value of 20 kilonewton meter. Portion DC may have a maximum bending moment value of 50, and portion BC may have a maximum bending moment value of 150. So among these three, what is maximum is 150. So this is what you need to find out. This is just for an example for you to understand. I have given you. Right now, this whatever I have explained now is tried in this problem. Even you can without all this, you can guess that maximum bending moment occurs in this region BC, where the load is very high in that region. But still, if you just say the maximum occurs in BC, then what is the proof? Okay, so let us try that. Right now, I have taken span AD first, as I said, span AD. Okay, now you take a section in portion AD. Okay, put a section somewhere XX. Okay, now you write mx equation for portion AD. So to the left of section XX, what loads you have? RAY and HA, only two loads. Okay, so writing moment equation is as good as writing moment equation in your beams. So mx value in portion AD is RAY into the section taken is at a distance of x. Okay, x is measured like that. So RAY into x, what is RAY? 65 kilonewton. So 65 into x. Okay, and left clockwise is positive because it is going to cause sagging. Next, HA into distance is y, vertical distance, the point where you have selected, and the line no, at horizontal line at point A. So HA, nothing but H only, into let me I thought of writing the value. Okay, HA into y. What is HA? 133.33. What is the direction? It is going to be anti-clockwise. So left anti-clockwise is negative. So it is 133.33. Let us see whether you got that equation here or not. You can see it here, RAY into x, that means 65 into x minus HA into y. What is this one? Y. You have derived what is y in the last session. Okay, so that we are using now. So minus HA into y. Okay, so this mx equation is valid from A to D. It is between A and D only. So what is x value of A? 0. What is x value of point D? It is 5 meters. Okay, let us see. This is what is here. So point D is at a distance of 5 meters. Okay, right. So that is the equation. Now, what do you want? Uh, Between AD, what is a maximum or minimum value? So what do you do? Dmx by dx is equal to 0. So differentiating that, so what you have, ray into x, all that. So differentiating that equation, so ray is constant 65, dou by dou x of x is 1, and ha 133.33, x square differentiation to x, and x differentiation 1. So that is written here. Okay, so by substituting HA value and RA value, you have got X value, that is 1.8748 meters. Okay, at this point you have either maximum or minimum value. Okay, right. How do you get m value? By substituting this x value into the moment equation that we wrote here. Okay, so once you write it here, you will get a value of maximum or minimum value of bending moment in portion AD, that is minus 14.06 kilonewton meter. So you observe here it is hugging. Okay, right? Okay, next. Right, for portion CB, okay, even by observation, you can see it here, as this is a maximum negative moment, and even maximum positive is possible in region AD, where even without searching for portion DC here, we thought of searching for portion DC, and it is well known fact that D has got a point load, so it is very clear that point D will have maximum value, not even at C or not even at D. So C is a hinge, moment is 0. Okay, D you have a point load and there is no load between CD, and hence we conclude that point D has got maximum bending moment, and that you can find it from by taking moments at D. Okay, so how do you write moment at D? Moment at D, you can write it sum of all moments to the left of D is again there are two loads only. You are taking moments at D. So RAY, that means 65 into distance is 5. Okay, again clockwise positive, minus HA, that means 133.33 into distance of HA from point D is Y again. So that Y you have to calculate from the equation by substituting x is equal to 5. So that will give you Y value, and that will finally you will be having moment at D value as 25. Now you can see uh, a complete analysis of portion AC is done. So moment at A is 0, moment at C is 0, moment at D where point load is there, moment is 25 kilonewton meter, and between AD you have a maximum value, that means in terms of negative moments 14.06, and you don't have any value maximum or minimum between D and C, and it only occurring at D. This is the complete analysis of portion AC. Okay, right. Now coming to portion BC. the right half of the arch. Okay, portion BC. Right, now take a section in that region. Okay, anywhere. You take a section anywhere in that region, XX you say, and that you measure it from this A. Okay, so you are now writing sum of all moments to the left of this section. Okay, so how do you write that? What loads you have? You see, you have RAY to the left of section, HA and 50 kilonewtons, and also part of UDL, this part of UDL. Okay, so this distance is what? X minus 10, X minus 10. Okay, so that how it is written, you see now, RAY into X, HA into Y, this is Y. Okay, and 50 into the distance X minus 5, then load into the span, just now I wrote it there, X minus 10, and the distance is half of that, X minus 10 by 2. Okay, so this is how you can write mx equation for portion BC. And a similar mathematical expression, dmx by dx is equal to 0. By differentiating with respect to x, that you will have x value, it is 17.5 meters. Okay, so at a distance of 17.5 meters, you have a maximum value. Okay, so x has come to be 17.5. So this is 10 and say 15 midpoint, 7.5. So total it is 17.5. I mean to say, so midpoint of this 15 is the location of maximum bending moment. Okay, right, let us see what is the value by substituting this x into that mx equation in the previous slide. So that will give you 56.25 kilonewton meter. So now you have three values of maximum or minimum, whatever you say. So minus 14.06 is one value in region AD, and maximum value of 25 at D, and now it is 56.25. So among these three values in the entire arch, the maximum value occurs in span BC, as we have guessed. We had a guess in the initial point of time that portion BC has got more load, so we expect more bending moment in that region. That is now proved. Okay, so what is the value? 56.25, where it occurs midpoint of BC. Okay, so this is how we estimate the maximum bending moment in the arch. Okay, right, thank you.